Hi children, welcome back to EDUHUNT classes. In this particular video, we are going to learn and discuss regarding the general properties of soluble bases or also called as alkalis. Okay, I have the heading for you. Here we go. General properties of soluble bases or alkalis. We know soluble bases are also called as alkalis, yes. So, we will see all the general properties, okay. There are mainly 5 general properties for this soluble bases or alkalis. We will discuss what is the one by one, okay. The first one is about taste, and the second one is regarding touch, okay. Now, third one is effect of indicators, yes, and fourth one is action with acids, and fifth one is action with ammonium salts. What is that, children? With ammonium salts. So, these 5 are the general properties need to be discussed in this particular video. Namely, what is that first one? About taste, about touch, about effect of indicators, about action with acids, and about action with ammonium salts. So, these 5 are the general properties of soluble bases or alkalis, okay. So, first we will discuss about the taste. Here we go with the first one. What is that? About taste. Taste of a soluble base or an alkali. We know soluble bases or alkalis generally they do have a dash taste. Guess what is that? I already told in the basic, the previous introduction topic. Did you remember, children? What is that? Alkalis have dash taste or else bases have dash taste. What is that taste? Hint, it starts with letter B, okay, it starts with letter B, come on tell me. Yeah, very good, it is bitter taste. Acids have bitter taste. What is bitter known as in Telugu? Bitter ni Telugulo emantam? Nothing but chedu. Inti? Chedu. Cheduga untayi kada, bases are chedu, not that much tasty, okay. Alkalis have bitter taste, which means it is cheduga untayi, okay. And this is all about the taste of a alkali or a soluble base, okay. What is that? Alkalis have bitter taste, okay. Now, coming to second one, that is about touch. So, if you touch a base or an soluble base or an alkali, what you will feel? Tell me. Alkalis, when we touch them, what do you feel? Which touch is that? Yes, soapy touch. Alkalis have soapy touch. In the sense, we can write like this also. When the solution is felt between our fingertips, okay. Whenever you take a solution of a soluble base or alkali, in the sense solution there in the, yeah, suppose soap is there, children. If you touch that soap, it will be little bit soapy, slippery. But if you add some water to it, what happens? It is more slippery, more soapy. Yes, norugochastadi kada. That's the reason I wrote here the word solution. In the sense, if you mix some solvent regarding that particular soluble base or alkali, what happens? It is more soapy to touch, okay. When the solution is felt between our fingertips, we do feel that soapy touch of the particular nature of the base, okay children. This is all about the touch of the alkali. In the sense, it is a soluble base, yes. Now, coming with third one, that is effect of indicators, okay. Third one is effect of indicators, we have some indicators to be observed clearly when we when we add the basic solution to that of the sample of a particular beaker. If we add some indicators regarding, there is some color change in that. Okay, we'll see what is that one by one. Okay, first one is alkalis turn, okay, alkali solution at light. Okay, one second. That's right. Okay, now alkali solution turn acidic red litmus paper, acidic red litmus solution containing thing blue. Once again, okay, the first one is alkali solutions turn, okay, I'll add red color only, wait. Okay, first one, alkali solutions turn red litmus, okay, acidic red litmus, wait, because it is acidic in nature, no? Acidic red litmus solution into blue, I told you, no, base which turns acid to blue, sorry, red to blue, it must be red to blue. Okay, BB, I told you, no, blue base, blue BB. Yes, so here we got it. The first one, that is the alkali solutions turn acidic red litmus solution into blue. Okay, so whatever you see when a litmus test happened, if you observe, if it is changing from red to blue, that is nothing but a base. B for blue, B for base. Okay, BB matching. Like that you can remember. Okay, this extra point for you. Okay, leave it. Now, next one is B. Alkali solutions turn, okay, turn acidic methyl orange solution into yellow. What is that, children? Alkali solutions turn acidic methyl orange solution, which color? Into yellow color. Okay, that is the second indicator property. And the third one is yes, alkali solutions turn, you know phenolphthalein? Yes, do you? Yes, alkali solutions turn phenolphthalein solution pink. Which color, children? Pink. From the colorless phenolphthalein solution into pink color is observed when you add an indicator in the base. Okay, yeah. So next thing is D. I'll write here. The next one is D. Alkali solutions turn, okay, are they only? Yeah, yes, turmeric powder. Actually, turmeric powder is which color, children? Which color? Yeah, yellow only, no? We can add here turmeric. Let's take with turmeric, yellow turmeric paper. Okay, we'll take yellow turmeric paper. Wait, not powder. Yellow turmeric paper into which color, you know? Into brown. Did you see that color, children? Is visible for you? Okay. Originally, the turmeric is yellow in color. We know, no? Pasupu. Turmeric means pasupu. So, maybe that particular paper that is yellow in color. So, when you add base, what happens? It turns from original yellow color to brown color. Okay. Now, this is all about the 4 effect of indicators in the particular common, the alkalis. Okay. First one is, if you take a sample solution of a base in the beaker, and if you keep the red color litmus paper, wherever the litmus paper touches the particular solution, turns to which color? Blue color. Okay. And next one, acidic methyl orange color. If you take again the sample of a base, and if you add some drops of methyl orange, it is generally indicator, children, which is something, a small bottle present, and that is orange in color. And if you add some drops of methyl orange into the particular solution of base, what happens, you know? It turns into yellow color. The solution turns into yellow color. But the indicator is in which color? Orange color. The solution will become not orange but completely into yellow. That is all about the base into changing from methyl orange color into yellow in color. Okay. Now next, third one. Okay. When you take again the sample of a base in a beaker, the solution of base, and if you add the colorless phenolphthalein, what is that? Phenolphthalein is colorless liquid, children, that particular indicator in a small bottle. And if you add 2-3 drops of phenolphthalein in the particular basic solution, turns solution into pink color. Which color? Pink color. Okay. Now next is taking a turmeric paper, which is generally yellow in color originally. If you dip in the particular basic solution, what happens? The paper turns into brown. Wherever it touches the particular basic solution, it turns into brown color. That is all about the effect of indicators. Okay. This is all about the third general property of the particular soluble base or alkali. So let's do with the fourth general property, and that is called as, what is that? Action with acids. Okay. So in that particular action with acids, children, there is an equation. I'll write for you. Okay. When you take alkali plus acid, it gives rise to what? Very good. Salt plus water. Okay. So whenever you take alkali solution plus acid, what happens? It generally gives you a salt plus water. Why it gives salt plus water? Why? Because alkali is nothing but a base. Yes. So acid plus base gives rise to salt plus water. Yes, very good. Okay, clear now? I'll write here for you. Wait. There's nothing but a base. Okay, clear? Yes. Now we'll see the examples, how the reactions are going on. Okay. Now the first reaction is, we'll take example number 1 is first example. Okay, example number 1. We'll take alkali solution such as calcium hydroxide, CaOH twice. Okay. To this, let's add an acid, the strong acid HNO3. Let's add it. Okay. It gives rise to a salt, namely, what is that? Calcium hydroxide, no? Nitric acid. No, what salt we'll get here, children? We also will get water, no? H2O. If you remove H2O from this equation, what will get? Very good. We do get calcium nitrate. I'll let big. Wait. Place is not sufficient. Just a second. Okay. It gives rise to CaNO3 twice plus water molecule. Okay. So whenever you intake calcium hydroxide plus nitric acid with 2 molecules, what happens, you know, it gives the products such as acid, which is salt, which is made up of this particular alkali, and mixture of this particular acid gives rise to a salt, and after that it is water. Okay, I'll write the names also for you. Wait here, I'll write here. This is named as calcium hydroxide. Yes, calcium hydroxide. And whenever you take calcium hydroxide with 2 molecules of nitric acid, we observe the liberation of calcium nitrate and water molecule. And here if you take 2 particular nitric acid, to balance we have read here 2 H2O. Okay, 2 H2O. Clear now, children? So first example is taking calcium hydroxide, which is a alkali solution. For that we are adding nitric acid, which is a acid, and what do we get? We get a salt, which is a calcium nitrate, and also water, H2O. Okay. Now second example is whenever you intake ammonium hydroxide. To this, if you add acids such as HCl, you get a salt, which is NH4Cl and water. Okay. So whenever you take NH4, what is NH4OH? It is ammonium. Tell me, ammonium hydroxide. What is it, children? Ammonium hydroxide. If you add ammonium hydroxide and also with the particular acid, that is hydrochloric acid or hydrogen chloride, what do you get? You get a salt, that is ammonium chloride. Very good. Ammonium chloride plus water. Okay. This is the second example for the particular action with acids. Okay. These two are necessary for you to understand. Okay. Whenever you take alkali solution reacting with that of particular acid, it gives the particular salt and water also. This is also called as which reaction, children? Which reaction? Neutralization reaction. Because why? Because we are observing the action of acid plus base giving rise to salt plus water. Okay. This is all about the action with acids. Okay. Now let's see with the fifth general property of soluble bases or alkalis. Okay, children. Here we go with the fifth property, that is action with what, children? Action with, very good, ammonium salts. Yes. Okay. So in this we do have also a reaction, that is what we wrote here with yellow. Okay. Here the action with ammonium salts is we are having equation also. Okay, for a better understanding, we will take ammonium salt. To this we will add alkali solution. Okay, hence to liberate metal salt. What is that, children? Metal salt plus water. Reaction is, I'll write something small or else wait. Okay, yes, plus water plus ammonia. Is it clear, children? Is it okay for you? Shall I write neatly? This is something messy, I'll write it neatly, wait. Okay, metal salt plus water plus ammonia. Ammonia gas, NH3, yes. Okay, this is the particular equation for the fifth general property. Okay, taking an ammonium salt, for this let add alkali solution to get metal salt plus water and plus ammonia. Okay, water, ammonia common, children. Okay, we will get all this. So here is example for you. First example, example number 1. Example number 1. So we will take ammonium salt such as ammonium chloride, NH4Cl. Okay. To this, let's add an alkali solution. Okay, the heading for you. Wait, heading I forgot to write. Yes. First, let's do with the headings. First example, example number 1. It is reaction with alkali solution such as sodium hydroxide. What is that, children? Sodium hydroxide. Okay. So first example heading, reaction with sodium hydroxide. Okay. So we'll take example 1, the reaction. Let's take ammonium salt such as ammonium chloride, and to this let's add sodium hydroxide because alkali solution, no? So what do I get? I get, what do I get? I get a metal salt. What is metal over here? Very good, sodium. Is there any salt regarding sodium? Very good, we have chlorine, no? We can write NaCl, the table salt. Okay. And what is that with water? Water is H2O, represented with H2O, and ammonia, NH3. Very good. See, it is balanced or not? Balancing? Yes. So I'll write the particular, yes, the states of this. Ammonium chloride is aqueous, okay, and sodium hydroxide is also aqueous solution, okay, and sodium chloride is aqueous in nature and water is liquid in nature, and coming with ammonia is gaseous in nature, gaseous form. Okay. Okay, I'll the names, the particular chemical names. NH4Cl is named as, NH4Cl is named as, very good, ammonium chloride, ammonium chloride. And what is NaOH? Heading itself, reaction with sodium hydroxide, no, sodium hydroxide. And to this, what we are taking? We are getting metal salt. What is this metal salt? Sodium chloride, and water, and also we get ammonia. Okay, this is the first example. What is that? Reaction with sodium hydroxide. Whenever we take sodium hydroxide to that particular ammonium salt such as NH4Cl, we get the particular metal salt, water, and ammonia. Okay, first example, reaction with sodium hydroxide. We are taking ammonium chloride, aqueous in solution. To this we are adding sodium hydroxide, namely it is aqueous solution only, and we do get a metal salt named as sodium chloride, NaCl, and water, and as well as ammonia. Okay, this is the first example for you in the action with ammonium salts. Okay, now let's take the other example, example number 2. The same equation follows, children. Okay, okay. Now example number 2, that is example number 2, that is reaction with potassium hydroxide. What is that, children? Reaction with potassium hydroxide. Reaction with potassium hydroxide. We will see the equation also. Let's take ammonium salt such as ammonium sulfate this time, NH4 twice SO4. To this I am adding alkali solution such as the given potassium hydroxide, KOH. Now what do I get? I do get the metal salt. What is metal over here? K. Very good. And salt, SO4 is there, we can add that. Okay. After adding, we get K2SO4 plus leftover ammonia and water. Okay. Clear? the names for understanding. This is named as ammonium sulfate. Okay, this is potassium hydroxide. Okay, next one is, what is this? Yes, potassium. S for 4 means, what is that, children? Sulfate. Very good. Now H2O is water and NH3 is ammonia. This is the second example for you. Okay, when we intake ammonium salt such as ammonium sulfate, and if we add to that with the base which is a potassium hydroxide, we get the metal salt respectively, potassium sulfate, water and ammonia. Okay, to balance this I will take balancing. No, I have to take 2K here, so K2 means you have to take 2 over here, and N is also having 2, so 2 here and 2 here. Okay, this is all about the equation balancing. And let's move with the next example. Are you ready? The last example for you. Okay, example number 3. Example number 3. Okay, example 3. This time reaction with calcium hydroxide. What is that, children? Calcium hydroxide. Okay, so this time I will take the previous example ammonium salt, that is called as, what is that? Very good, ammonium chloride. To this I am adding calcium hydroxide, CaOH twice. Yes, given calcium hydroxide is there, no? CaOH twice. Now what do I get, children? I get the metal salt. What is the metal over here? Salt. Okay, Cl twice, because the valence of calcium is 2, so Cl2 plus water molecule and plus ammonia. Okay, so after balancing, what do we get? Here H4 is there, H3 is there, calcium is 1, okay, satisfied. OH is twice. Okay, here I'll write it 2NH4Cl giving rise to 2H2O and 2 ammonia. 2N satisfied, no? H. Okay, so this is all about the equation and the names for you. Names here as follows. NH4Cl is ammonium, you know it already, no? Ammonium chloride. To this if I add calcium hydroxide, very good. Next is metal salt. What is that? Very good, calcium chloride. To this we get water and we also get ammonia. This is the equations. Okay, the examples 1, 2 and 3 as follows. Okay, again I am telling you, action with ammonium salts include ammonium salt plus alkali solution giving rise to a metal salt, as well as with water and ammonia is common. Okay, so in that we have example 1, reaction with sodium hydroxide taking ammonium chloride and sodium hydroxide giving rise to metal salt, sodium chloride, water and ammonia. Okay, next if you observe second example, reaction with potassium hydroxide KOH, we are intaking a special different ammonium salt such as ammonium sulfate, NH4 twice, SO4. To this we are adding 2 molecules of KOH, potassium hydroxide. To this we get a metal salt named as potassium sulfate, K2SO4 plus water molecule and ammonia as well. Okay, children. And this third example we have reaction with calcium hydroxide. Reaction with calcium hydroxide. To this we have taken the ammonium chloride also, NH4Cl. We added calcium hydroxide, which is a base. Yes, we got it. A metal salt that is called as calcium chloride, water, ammonia as well. Okay. Here if you see the nature, the particular forms of the examples, this is aqueous, this is also aqueous solution, this is also aqueous solution, water is liquid, ammonia is gas. Okay. And here if you see ammonium chloride, in this particular reaction, it is acting as a solid. Calcium hydroxide is also solid, calcium chloride is solid, water is liquid, ammonia is gas. Forms generally for ideas that I have given you, children, no need to worry regarding that. These are the examples of particular, yes, action ammonium salts. Here you got the things, no? Once again I am showing all the slides for you. Just see the examples, ammonium salts examples, okay, and with acids, okay, effect of indicators, touch and taste, and the general properties. This is all about today's class, children. In this particular video, you got all these things, no? What is about taste, touch, bitter in taste, soapy in touch. We have different indicators, and actually acid gives salt and water, examples I gave you, and also ammonium salts, okay. These are the 5 general properties of soluble bases or alkalis discussed so far. So here ends the session, children. Thank you.